Let's get to transforming data. Often you want to create a new column in your data frame based on one or more existing columns in your data frame. Or it could be any arbitrary transformation. For example, you want to take a log of a numeric column or square root or square. Like this, there can be n number of transformations that you want to do. In this one, we are going to work with the tips 100 dataset. What this contains is, this contains transaction information about 100 different transactions for a given restaurant. This is completely fictional data. Even though you have columns like credit card number, payment ID and all, this is completely fictional. So no privacy information over here. Also in this data, you have the total bill, tip, information about the customer, the size, number of customers visiting for that particular bill, so on and so forth, right? This information you have. Suppose you want to create a new column based on this information. Suppose you want to create percentage of the tips, that is tip divided by the total bill. Or you might also want to create a column like tip per person. How we would normally do it is, we will use the df.log function, open colon, open brackets, then tip percentage equals to df.tip divided by df.total bill, this column. This is the usual way of creating a new column in your data frame. But imagine you want to create 5-6 different columns in your data frame, right? That would involve creating 5 different statements like this. That can make your code a bit cumbersome. What you could instead do is combine all of those statements into one single function, which is df.assign. Within df.assign, you can create as many variables as you want in one single function call. So the code for assign is quite straightforward and it looks something like this. Here you have df.assign, name of the column that you want to create, then define the logic in a lambda function, the logic that you want to create, and that's it. Now, how you write this lambda function is important. That is, the argument that your lambda function receives is one single row of your data frame at a given time. So suppose if this is your data frame that has a lot of rows over here, at any point in time, the value of x will be the entire row at a given time. So this computation will happen row wise. The entire values of a given row will be taken as a series and passed on to this x. From this row, you can extract the respective columns, x tip and x total bill. From this, you are extracting it and doing your computations. So that is how you write a .assign based column assignment. All right. Next function is map. Map is a very useful function, often used. There are two different very common use cases for the map function. Let's understand both of them with an example. First one is, for example, we have a column called day. This contains the different days of the week in text format. We want to convert this into numbers. For example, we want Monday to show up as 1, Tuesday to show up as 2, and so on. To do this, you can use map and pass to it a dictionary argument that gives the mapping of each and every value in your column to the corresponding value it should change to. For example, Saturday, Sat, you want to change it to 6. Thursday, you want to change it to 4, and so on. So first you need to create that dictionary, then pass that dictionary to the map function. Let's see how it works. So here this is the dictionary, Monday equal to 1, Tuesday 2, and so on. Then we take that particular column. Now remember, this is a series. The map function applies to a series, not a data frame. All right. To this map function, pass in the dictionary that you want to map it against. On running this, you should get that reflected. The change is reflecting in the day column. Correct. Now let's see one more function, not just dictionary. You can use a lambda function also inside map function. Here we have the credit card number, right? We want to mask that credit card and show only the last 4 digits. And you can do that this way. You define that lambda function. This lambda function's x, right? This will take that entire series as an argument. No, not the entire series. You are given the series. You are applying the map on a given series. It will take each and every cell of that series as the argument, right? So x, this particular value will become x. From this, you are extracting the last 4 items of that particular cell, right? That's what you are doing here. Let's run this and see the result. So this is a typical way credit card information is masked, right? Now, sometimes certain credit card information might not be valid, where the length may not be equal to 16. In such cases, we are first doing the check about the length of that particular cell, particular credit card number. If it is 16, then use this logic, else use this. So now that is reflecting in your CC number column. When the length is not equal to 16, you are getting XXXX. So those are the two main useful cases of using map. One is using the dictionary and passing it to map, or you use the lambda function and pass to map. Alright, next function is apply map. Now suppose you want to apply a given logic, to all the cells in your data frame. You have the apply map. Just like how the map function works for a series, the apply map function works for the entire data frame. Right? So what will the argument value for this x in your lambda x for apply map? So you have the data frame, you have a lot of cells in your data frame, right? This x will receive one single cell at a time. One single cell will be passed on to this x. Like this, all these cells in your given data frame will be passed on to this x, and this transformation will be applied. So here in this task, for every cell in your data frame, if it is a character cell, then we are replacing that character. For instance, you have the column sex. This contains characters male and female, right? Instead of having male and female, we are going to replace it with the very first character and make it into uppercase. So this male will become M, female will become F. Likewise, for smoker, no will become N, yes will become Y. So this is the logic to do it. Let's run it. And the output is shown here. So here in this case, you see that the pair name is still untouched, even though this is a character. That's because the pair name contains the space character, and that space character is not considered an alphabet. To make that work for pair name also, we are replacing the space with nothing and then running the same logic again. In this case, I'm actually not using the first character. I'm replacing it with the length of that particular string. That's okay. So in this one, we have covered three concepts. First one is assign, second one is map, and third one is apply map. Very useful functions. You should definitely get a practice on this. So let's do a mini challenge. The challenge is you have the tips 100 data set. In that, you have a payment ID column. From this column, extract the day of the week, the string part of the day of the week alone. That is, this payment ID contains, say, SAT followed by some digits. Some digit will be there. From this word or character, extract this portion alone for all the values in that particular series. If you have access to a computer, give it a shot. Otherwise, imagine how you would even solve this. Let me show you the answers. So the solution is, we first take the series. On that series, you are going to run this remove digits function that is defined here. On doing this, you should get the desired result. Let's run this. So that's how you can do it. Congratulations if you got it right.